We interrupt this coding session to begin to bring you Rubber Duck Engineering. We were deep in the codes before you joined us, and now we're going to return to the codes for our 71st episode in which we trace, for real this time.
The third time is the charm. It's going to happen.
Third time is the charm.
Okay,
So
we were debugging this unit test.
yeah, well, I wrote some code on the weekend, but it didn't actually work, and so we're making it work before. It's still before the show, right, Dr. Barth?
Yeah, this is the green room. Welcome to the green room, everyone.
Welcome to the green room.
So we furiously. So okay, so I think the this new test fails, right? The index is out of bounds, is what it says. And I think we just have it off by one error.
Yeah. So what we're doing here is that we reduced our unsafe count significantly, although we just added a really bad unsafe in the green room. But I have no idea if your unsafe is even remotely on the planet safe.
To recap, in the last episode, we corrupted the Rust heap.
We did corrupt the heap. That was an achievement unlocked.
We did in overtime after the show last week. We did manage to make a one-line fix to uncorrupt the heap, but we're following up on actually the suggestion that Eric had in the middle of the last show, which was instead of destroying the box for the host object, we're just going to try to leave it in a box and let the Rust machinery do a lot of the work for us.
Yeah. So now in the heap inside the inner, inside heap inner, we now have this object cells where we just hold on to the weak cell and the weak cell holds on to the box.
Okay.
And then
now what we're trying to do is when you have a handle to one of these objects, we're trying to get you an actual reference to the object.
Yeah, so we wrote a new
quite close
number. Yeah, we're close in terrible, scary ways. But we wrote this new test, number as a host object test, because it turns out before we were never actually trying to grab into the value of these things. And I worried that this would be a problem in this model because we're holding all these boxes. And if we tried to grab into one, we would hold on to the reference of the whole value. But anyways, we were fixing.
Yeah, so I think, do you want to go look at line 245?
245.
So you push this thing onto your object cells, and then you claim that the index is the length. And I think you mean length -1.
Yes, that is correct.
Okay, so can we try the test again?
Or I could just put this before the push. Either one works.
Yes.
Okay.
Woo! Okay, so we were only 3 minutes of green room away.
Well, yeah, we still have to sort of explain. So if we look at the history, oh, you can't see this. I have a fancy new setup. So hopefully this is the correct size. I got a new monitor this week. And so although you can't see it, I'm only projecting a single window, and then I have other windows open because I have so many pixels now.
Crazy. Okay, can I make a suggestion? Can we commit right now? Because we have the passing tests. And as we learned from our previous episode, that's a very special moment that we want to record to make sure we can always go back to in case we want to.
All right. Okay.
Excellent. I feel much safer now.
Oh, so I can't easily show the history. I guess show ahead till the 1. I don't know how good this will look. But I did a few things in this change. I made this thing a library, and I also moved the tests out into an API tests.rs so that we could actually use this dead code elimination. And that forced us to make things pub and not pub. I don't know, I did too many things in this one change. I should have made this change more self-contained. The real original goal of this change was to get rid of, you can also see that I have like a sort of a pseudo finalizer queue, except then I immediately empty the pseudo finalizer queue. So it doesn't actually bring us to any safety. Let's see, anything else we do here? Yeah, we do this. Remember we were used to like reconstruct a box. Or
So
no,
the
this
host
isn't.
object finalizer craziness is gone.
Yeah, the host are. Yeah.
We use box because box can do all this.
Instead of having a value pointer, we now store this value index. Those are fun. Yeah. So this is pub. It probably shouldn't be. Anyways, this was a change that I half finished, but then we frantically tried to finish in the last 2 minutes before the green room. Is there anything else worth showing here? Yeah, I mean, this is our new test where we make a number, but as a host object this time. So like Rust manages it. It's a little wild that we do that because it's a little weird that you have both this number that's not a host object and then using the number as a host object, but that's it. Okay.
I think we should do tracing. Let's do tracing.
Tracing.
This is the third time we try to do it.
So make a host object with a finalizer.
Boom.
We did this.
Done. Deleted. Success.
Number 4. Let's trace
Excellent.
these.
So, trace objects.
So now we have to have in order for this to be real, we have to make a host object that contains pointers. So like if we had like a vector object, right? Like a list object would be something worth tracing.
That's a good idea. Yeah, so I think we have a global handle. I think we need to make another handle type called heap handle. And then if you want to have heap handle will just be basically a wrapper on object pointer. And then we'll have a vector of heap handles in a host object, and then we'll try to trace that. Does that sound plausible?
That seems plausible. Why is the host, when you say inside a host object, what does that mean?
So the idea is you have a host object.
Mm-hmm.
Let's say it could have a vector, it could have a hash table, it could have any kind of thing. It wants to have pointers back into the heap.
Yep. That's why we need this new pointer type.
Correct. And so then now when we do garbage collection, when we go tracing, we're going to have to ask the host object, hey, do you have any pointers back to the heap that I should be following through the heap?
Yep. Okay. All right, let's do it.
Okay.
Somewhere down here. I don't know, whatever. We just got to
Pick a place.
pick a place. All right, right here. Oh, I don't know if this needs to be REPL C and all that, but sure. Pub struct. This is list. Is it just list? Does it have a type T?
No, let's just make it concrete. Why don't we make it just a list of, yeah. This is fine.
Well, eventually we're going to need like a value type, right? And like all lists will just have a value, or whatever. Like we need some sort of generic.
These actual objects you're going to do in your Ren virtual machine. So these are just like example objects that we're using to test the machinery.
That's true. So this is to me like a number list.
Sure. Well, this is like literally vec.
Vec, yeah.
This should be vec of heap handle.
Okay. And
so we need a trait here. It's like traceable.
Mm-hmm.
You like that?
We need to implement that trait, and that like takes a trace. I thought we had one of these. We do not. Okay. Oh, I can click on you here. That's useful.
Heap handle. This just has a.
This needs to be like fn trace, and it needs some like context, right, that you're adding to.
Mm-hmm.
Like that. And then is that it? Traceable?
This should probably be a mutref to the trace context.
Yep.
Seems good.
Struct trace context.
Mm-hmm.
I don't know what it's going to have, but it's going to have an impl. Just going to be like and add.
I think traditionally call it accept.
Whoa,
This is
what
gonna
does
have-
accept mean?
You can call it whatever you want. You call it add, but that's a.
And this just basically means I've seen this.
Or like visit. Visit might be a good name.
Yeah, visit.
Like,
Yeah, this is like a visitor. I feel like I've seen that before.
yeah, so this is like a, maybe this is a trait then. This is like a heap. Or
Oh,
is it?
why is it a? Okay. Well, you're going to end up typing this a lot, so you kind of want it short.
Okay, make it visit.
But why is it a trait and not just a struct?
I don't know. We'll see when we try to actually implement it.
Oh, because you think you're going to end up like passing the heap itself.
Well, yeah, somehow we're going to have to integrate it with our collect function, right?
Yeah. Okay.
So-
I think that's reasonable to say that this could be an object.
Well, yeah, okay.
That's fine. This can be an object visitor. Okay, great.
Right. So let's implement this for this. Impl traceable.
It's complaining about this. Okay.
It's going to need like a.
Object visitor cannot be made into an object.
Let's just make it a struct for now. We'll figure it out as we go.
Yep.
But this will just make the compiler complain less.
Yep. Impl. Yep. Yep.
And then the key for this is because this is a mutt heap handle, this is going to change the pointer inside the handle as it goes through the.
It's going to change the pointer. This also needs a self.
Yeah. Right. So you're going to say, hey, visit this handle. And what this thing is going to do is it's going to move it to the new space, and it's going to change the pointer inside of it.
I guess it also could just add it to a visitation queue.
Well, eventually, somehow the pointer has got to be changed.
Yeah, I don't know whether it's done immediately or, but yeah.
Visitor mutt. This is visitor now, not context. Visit. Value. Okay.
Yep. And it looks reasonable.
Okay.
Fields never read. Handle. Yep, fine.
Okay, so now we need to implement object visitor. So why don't we put that up close to our collect function, because it's going to be pretty related to our collect function.
Okay. I think you're right. It's going to end up being a trait.
It may end up just being a heap or something. But right. So what are we going to need as we go through these things? We're going to need to remember whenever we moved an object. This may just be the heap.
I think it is just going to be the heap, but it doesn't hurt it to be a trait. I just don't know how to express that correctly.
Well, we could just make it a trait, like trait.
It's the it's used. Yeah.
And we'll say impl visitor or object visitor.
Because I guess traits are like abstract classes. Is that because in C++ this would definitely be like an abstract base class.
They're like abstract based classes. They're vtables.
Okay. So impl object visitor for heap. Yep.
Now we're going to, in our object header, we need some more state. So basically what we're going to do is we're going to say header equals handle.pointer dot header. How do we should be able to get the header from an object pointer. Here's object header from object pointer. We just add this as a function on here. And header. Basically, we need to say like, if we've already, what is it, man?
Expected struct object pointer found reference to object pointer.
Oh, just put a star.
Okay.
So I was gonna write some pseudocode here. So like, if we've moved this object already, then what we want to do is update handle to point to the new location.
Mm-hmm.
Okay. Otherwise, add this object pointer to our queue. Otherwise, allocate space for this object in the new space.
Mm-hmm.
Update handle point to this newly allocated spot.
Mm-hmm.
And then add
very much like collect.
And then add the pointer to the queue of objects needed.
Mm-hmm. Okay. So these two need to end up being functions that we share with collect.
Mm-hmm.
Or like this thing, right? To like move or update, or whatever.
Right. Yeah, it's very similar to what we're doing here around line 170, right? Is that what you're getting at?
I don't have the line numbers memorized, but
yeah. So basically, what we should do on here is when we scan the globals,
mm-hmm.
we should just add them all to the queue of things that need to be scanned, and then we should run this visitor loop to actually do the work here.
Mm-hmm. Yep, because otherwise we weren't recursing correctly.
Mm-hmm.
Mm-hmm.
Yeah, so it looks like when we allocate them, we actually have to move them. So we should add that to our list. Update, allocate space to new object, the object over.
Well, again, it needs to be a shared function. Because you don't want to write that code twice, right?
Oh, absolutely not. Do you want to start refactoring collect into pieces so we can start using it?
Okay. What's that collect here?
Because like we're just saying, we just rewrote this pseudocode, right?
Mm-hmm. Just pages it in. I see, and this is the trace the object graph.
Yeah, like somehow we need to like after we do this, like do like add.
Or I'm gonna grab our pseudocode. Here, this thing. Here and compare. All right. Collect. So, and this thing operates in handles, whereas this operates in object headers.
Because I think we want to operate on object pointers.
as opposed to these headers?
Well, object pointers and headers are, we can just operate on headers. The headers are,
Okay, and so this is the pop it off, right? So every time we hit a maybe cell, if we got the heap cell, we need to grab out its header. And then we're done with the cell at that point, right?
yeah.
Oh, we update it here. But that's happening a second time. How are we going to find the cell for this?
I think this function should return the thing that we put in the cell. Like, I think this part here
Has to be synchronous?
is the part that goes, yeah, I think this part is the part that goes in the function.
Okay, that makes total sense to me. Oh, cutting it out. And move, whatever. The header. I took the lock by putting it in my paste.
Yeah, it's fine. Go for it. I feel like I dominate the keyboard in these episodes, so like
It's okay.
More than happy to let you type.
Well, I'm finding, that the weekend hacking is so much easier for me, when it's just quiet. I'm not also talking to an audience while I'm. It's a skill to have to talk and code at the same time. All right. I see. You got our self pointer. Okay, and then we have to return. You said.
I guess we'll return the
Object pointer.
We return the object pointer, sure.
I don't know.
Yeah, why not?
All right. I don't know if this factoring makes any sense, but
And we just inline this. We don't need a variable for it anymore.
okay.
Check this. What I would call this.
Okay. But this needs to add to the visitation queue.
Well, I think this is actually. Yeah.
Right. We currently depend on this being synchronous here because we don't have a way to get back to the cell to update it. That first level.
Right. So we need a queue somewhere.
What happens when we're in a recursion and then we have cells to, like, say the next when we're calling this function later and we need to update these cells, does that have a way to do that? This in inner globals.
The cell is all updated. The cell is fine. We just need to remember that we need to visit this object.
That's, I mean, is this just the same as self dot? Is it?
Well, I think somewhere we need a queue. So why don't we add a queue to our data structure? Right. It's like up here, we're going to need a
visitation queue or whatever.
Yeah. I'm not sure if this is exactly the right place to put it, but we'll start here.
Mm-hmm.
So of what is a good question. Maybe object pointers. Like these are the objects that we need to go visit.
Well, you mentioned that a handle type, like a local handle or whatever, but maybe that's later. And do you ever want object pointers or do you want header pointers? I guess you can swap between them.
They're interchangeable. It doesn't really matter.
Okay.
Like, did I spell visitation right?
I don't know. I can't spell my way out of a bag. It appears you spelled it correct. Or visitor queue. It's like other things called it. and a vecdec.
VecDQ, yeah, because we want to add to the front and pull from the back. Just a data structure that does that. It's in SCD collections.
Oops. A quick fix? Thought they did.
Oh, there's a light bulb to the left. Does the light bulb know how to do it?
Oh, light bulb. Show me the light bulb. No.
Those are all the wrong things, light bulb. Here, I'll just add it.
Unresolved import. Standard collections vecdec.
Right. So I think that this thing. So move is a little bit too concrete, right? We need this branch, right? That we've written here in the pseudocode. So if that, because the object header knows whether it's been moved, right? Because it has a isn't there a field in the object header that's like, yeah, the new header pointer.
Mm-hmm.
So like at the beginning of this function, we need if let some new header pointer equals header dot new header pointer and return.
I gotta find you. I was making your vecdec work here. I thought I had figured out how to find you on the right-hand side, but oh, there you are. A rogue Adam appears.
I'm just thinking we want to do this, right? Visitation queue, push back, pointer. If we've already moved this object, then great. Like this is like move. It's like new object pointer in new space. Okay. If it's already been moved, then that's great. We just grab the object pointer.
Yep.
Otherwise, we go copy it over to the new space. We remember that we did that, and we remember that this is now an object that we've moved over that we haven't scanned yet. We haven't traced yet.
I see, because we've obviously already traced it if it has a 2 object pointer.
I just think we just maintain the invariant that we, as we move things over, we remember that we have to trace them.
Why are we? Why does it? I don't think this is the right. No, I don't think this is the right call here. I think this needs to be object. I don't know how you get the T out or whatever. And then you want to call like trace self. Here. I don't think you want this.
Okay.
Because what we really want is we want the children of this object to get added to the visitation queue. We just visited this thing. That's what this is really like visit.
And this is the difference between depth first and breadth first.
Well, what are you going to do with it? So say you put the push back. What are you going to do with it when you pop it off? You're going to do this again?
Yeah, so it's just a question of whether you want to recurse through the object tree, or whether you just want to have in collect just have a loop where you drain the visitation queue until it's empty. So you in this model, you're basically always calling trace directly from collect, as opposed to calling it recursively.
I'm not sure I follow what you're trying to say. You think this works? My concern is that we're going to end up executing this code. Like, we're always going to end up calling. We're always going to come into this if, because we're going to always do it once, and then we're going to call ourselves again. Right?
It depends whether. So for trace, the idea is you get called back for all of the children, but not for the self object.
Mm-hmm.
Yeah. And so this is about the self object. So trace will then process the children.
All right, when do we call trace?
So I'm imagining here, after we've gone and done with all the globals, then we have a while let sum next equals self dot visitation queue up front, and whatever it is, basically the moral equivalent of this. We have to figure out how exactly to do that, but
what do you mean? How to do what?
This line of code doesn't compile. Like we have to figure out how to get to the actual trace function. Like
Yeah.
We need to figure out like, is this the thing that's traceable, etc.
And this thing does do the copy. Okay. Don't we need to hand it the place to put it? Oh, I see. This is it always knows where to put it. It's in the to space.
Mm-hmm.
This is tracing only happens during collection, basically.
Collecting and tracing is like this cooperative process.
Mm-hmm. Okay. So this is the problem. This is our next problem to solve, is that we don't know how to get from the object pointer to a thing we can call trace on.
Correct.
Because we've lost the T?
Yes. But let's come back to that. Because I think we can write the trace function now.
Okay.
Visit object is just
I don't remember where it is.
Or line 280.
Okay. I'm sorry. So this takes the heap handle, which is a new kind of handle that it grabs the pointer for the header out, and then we update the header pointer to the new object pointer. Why does that make sense? Does this one update the cell pointer? Does this one also need to update the object pointer? Oh, I see. This is the handle. Sorry, I read it as the header. Okay, yeah.
We could probably get rid of that. We could probably just put this here.
So these are the same code. One is just operating on cells, and one is just operating on heap handles.
Right. So in one case, you have a global that you're updating. In this case, you're updating some pointer inside of some host data structure.
And these that makes sense that these should be identical.
Okay.
And then maybe heap handle, and the other one's just called global handle. And this is called local handle or something like that.
Oh, we'll also have a local handle.
What'd you say?
We'll also have a local handle. But
okay.
We'll end up with 3 kinds of handles, but that's fine.
Okay. What's next?
So I think we need to make that line compile.
Okay. And that's because the object pointer, which we're operating on, doesn't know what it is.
Mm-hmm.
Does the header pointer?
So I think what's going on here is I think we need to
we need to only we only care about doing this for the host objects.
Right. So the header, we're going to need some sort of like type information in the header to be able to interpret what the object is. So why don't we add a
rule that says that it's a host object, and then we can tee our way from our object pointer to our host object.
Yeah, but it's going to be more than a bool. So let's do an enum. Type primitive.
I need to find that follow you button again.
Our object header is getting kind of big, but we'll be able to compress it down later.
Yeah, we'll fix that later. Did you ever see the movie Thank You for Smoking?
Yeah.
I struggled to remember this last week, but there's this scene where the Thank You for Smoking guy, the lobbyist or whatever, is trying to convince the movie executive to like have the whatever Matt Damon and some other star or whatever, smoking in space. And the lobbyist says, well, isn't that an all oxygen environment? And the movie executive says, oh, we'll just fix that with, say, oh, thank God we invented, non-flammable cigarettes or whatever.
Thank God we invented object types.
Yeah. So I don't know. That phrase, that scene comes to me often, and here it came again. It's like, yeah, we'll add an enum to object type later.
Okay, so now we need to add this to all of our things so stuff compiles. So when you can do one of these, you got to give it a type. Okay.
I see. So basically, we check to see if the this trace becomes an if. It's like if object type is global type, okay, cast it, trace it.
Yep. Yeah, exactly.
Yeah. And this object type, we're starting to seed. Yes, we're starting to seed the magic of the tag pointers.
Correct. Yes. This is now just object type primitive. Okay. And this is here type host. Okay.
Okay.
Yeah, when we go, we use tag pointers and everything to compress down the object headers.
Yeah. We'll get to that.
So we're going to do match on next dot header.
Mm-hmm.
Type.
Yeah.
Do nothing.
Mm-hmm.
Type host.
Yep. We need a trace.
Right. So now we need to.
It's like next.adder as t or something like that, as star t or something.
We don't need to know the t yet. We just need to get the index out of it. Like, suppose we knew the index.
Oh. Oh, well. Oh. Well, we could use a trait again.
Well, I wonder if for the host object,
you just can't. I see. The problem is global handle has a type, and you don't know which. Or it's the host object has a type, and you don't know what type it is.
Yeah, but what if we erase that? Do we need that?
What if global object didn't have a type? Does that matter? Or host
I kind of just want to like.
It may not, especially if we have that get out at the handle level. Well, you need the T for the get.
This stuff is all simple in C because in C you're just like, oh yeah, this is the memory layout. Like it's in one integer. Give me the integer. So we're sort of.
We also just blindly cast in C. and hope for the best.
Yeah. The only bummer with taking out this is it like that test we wrote to get the this part here won't work anymore.
How is get object implemented again? I need to stop following you.
I was just looking at line 320.
I don't know why I'm no longer. I must have stopped somehow. Yeah. So this thing, where do we
This
get
thing is making use of the
there.
T. I mean, like, we could just say,
well, if this was a trait, right? Don't you know that host object is traceable? Oh, host object itself isn't. The T inside is.
I mean, what if I just knew that it was a usize? Like how do you I know what the memory layout is. I want to be a C programmer.
Oh man.
I was getting a little tripped up by all this fancy Rust type stuff. Like we could just say, right, like, oops.
We could just reinterpret whatever the Rust is. It's like the mem.
Yeah, like transmute or whatever.
Yeah, mem. Yeah, something like that.
Okay. And maybe this is horrible.
Sure.
I would just say like object pointer as star const usize.
Well, what if well, oh. Well, so what if you did what if you did, oh, hold on, where did I go? Oh, I'm following you again. Stop the following. Okay, where did we go? Okay, so it'll come to me. Can you cast it to object? Or sorry, not host object any or whatever, or host object, dyn traceable. Shouldn't that be possible?
I don't think that's gonna work. Let's try this because we want to get it through the.
So why won't my slightly safer thing work?
Because it's not like the dyn traceable is not guaranteed to be the first V table. Like let's say you implemented 6 different traits.
Uh-huh.
For T, like you don't necessarily know that T and dyn traceable are the same thing. Like it's the wrong type. Like that's why we have the any, right? We don't want to recover the type from the host object. We want to go to the cell, get the any, and then do the casting on the any to get the dyn traceable out of it.
And why does the host object need to carry the T around? Because somebody does. Maybe these maybe when we get to the tag pointers and whatever, there's going to be like we're going to get back to our value enum, which it will carry the T or know the T.
Yeah, I think we're I think there's something wrong with our host object type declaration that we can work through.
Okay. I mean, This is super unsafe. It's like a cast and pray kind of code. Cannot borrow header as mutable. It's behind an at reference. Why is it mutable here?
Oh, you just make it mutable? We're going to assign to it, right? So it'll be a mutable reference.
Sure, yeah. Mismatch types. Expected mutt header and got header.
All right, we'll make that a mutt pointer. Or make a mutt header.
I think we're just not, we're not making any attempt to respect mutability here. Oh, this one does. Okay, and so
this would be a mutt header like that.
Okay.
I think returns a mutt.
Cannot borrow self mutable because it's already borrowed as immutable. Self is mutable because it's already borrowed as mutable. Immutable. I see, because it's borrowed. Immutable occurs there because we're borrowing the inner. And then we want to mutt borrow it during this thing.
Okay.
Which makes some sense. Why was this working before?
We hadn't broken it into a function.
But why does this thing need to be mutt self? Probably because
I mean, it only needs the 2 space. So maybe we should just pass in the 2 space.
What if we just did that? How does it break?
Because we need a mutable reference to the 2 space.
All right, we could just pass in the 2 space and bust this out.
Yeah.
Oh, we do self visitation Q2, which is mutt.
I see.
All right. Well, let's see. Where are we? This is Rust. Fighting with the Rust. Shall continue.
We can just take the whole globals out, right? Like we don't need to hold all of this thing during the iteration.
Oh yeah, definitely. We just because we don't clear them here. Yeah, we just copy the globals out. I can't do that. Probably hold it. This isn't copied, does it? All right, cannot find inner in the scope.
We just need to say inner equals
cannot move out of. Yes, this is a move. You would want to copy this. So this is like clone or something?
Oh, I don't want to copy it. I just want to let.
Oh, so you want like take.
Oh, I see. I think it's fine, but I can just swap it in and out.
I think there's dot replace or something that does the same thing.
Does vector have a take? Like
no, but
I think there should be a way of like I want to move you out and leave an empty vector behind.
You would think that this exists like a swap, basically. Yeah, swap. Let's do. No, that swaps 2 elements.
That's okay. And the swap thing will work too.
All right, fine. All right. Where are we? Cannot borrow inner as mutable. It's not declared mutable.
Problem solved. Insert more mutts.
Unused variable value index. Okay, so we grabbed the value index, but we didn't do anything with it.
Right.
So this is where we need to do let object equals inner dot. What is it called? Pro dot object cells dot.
I think value index, like square bracket value index.
Oh yeah.
Mm-hmm.
Yep. But really, we just need to want to call it trace.
Yeah, we need to.
But it's
Well,
going
it's
to be sad.
it's an any, so we have to. We wrote this code somewhere before. This one. This code here.
I don't see where you are.
Oh. I'll just copy and paste it over to where we are. Right?
Oh my
As
god.
ref, unwrap.
We are fighting Rust so hard here.
Yeah, well, we're trying to manually screw around with the memory. Okay, so now this thing we want to downcast to. Now we want to write dyne traceable.
There are many cleanup passes needed on this code.
I'm just trying to get to something basic here. Oh.
You mean visit? I think you mean trace, don't you? Oh. Oh, maybe we did call it. Yeah, I don't
trace.
remember.
Downcast ref cannot be invoked
On a trait object.
So just for concreteness, let's try to make this number list.
Why does this? But why do you even need this? Doesn't why don't we just make value here be traceable? Why do you need to downcast it?
Okay.
We don't accept any things that are not traceable.
That's a good idea. We can write that up here, right? Where we say.
Yeah, we need object cell. This thing is currently, or weak cell rather. Any plus traceable. What was it before? Was it really any?
It was just any, yeah.
Oh yeah.
This is fine.
But why is it any plus traceable? Why isn't it just traceable? Dyne traceable.
Because we need to be able to downcast. We use the downcasting ability elsewhere.
Oh, I see. That's what the any is.
Yeah.
Auto trace can only be used. Only auto trace can be used in additional trace in a trait object.
What is an auto trait?
Trait, new trait, any plus tradeable.
Oh,
what?
Okay. That's we just can declare this here. We could say, is it like type?
Well, it had it right there. If you go back.
Oh, sorry. Go for it.
Move that. Oh. Okay, we just can pull up this E25, whatever.
Oh, I see.
Anyways, we do trait, new trait, colon, any plus traceable. Mm-hmm.
Colon?
Yep. Yep. That's correct. Semicolon. Yep.
A name for it.
New trait. Great.
Weakable.
I have no idea.
Arrow?
I don't know why this wants. Why does it want wanted the semicolons there? That doesn't make any sense.
This is super weird syntax. I've never seen this syntax.
Trait bound T weakable is not satisfied.
Okay. We'll scroll up.
That's
What is
because
dyne?
we haven't made number list weakable.
Well, no, this function needs to declare it. There, you just need to say plus traceable.
You mean here.
Yep.
Okay.
You can also just say weakable. Like T weakable. All right, same thing.
Okay, no method named downcast ref.
I think we this weakable declaration looks super weird to me.
I'm looking at the Rust. Multiple types were used as bounds for a closure or a trait. Rust does not currently support that, supposedly. This is E0225. I can chat it to you. The error we had.
Okay. Do we just need to define this for host object?
Maybe. That host object must be weakable or whatever.
No, not that it's. Oh.
I don't know. I'm well off my Rust knowledge.
I feel like we've gotten lost here in Trayland.
Yeah. I think we need to abort back, particularly since we're like we promised tracing.
I think we have actually written all the code that does tracing correctly.
Okay, I believe you.
I think we just have to make the Rust compiler accept it, and then we'll write a test. Maybe.
So what you're saying is that it's going to happen in the green room 3 minutes after we close the show.
I mean, by 3 minutes, probably like several hours, but yeah. But no, but we have the right thing, right? We have a thing that moves each object, adds it to the queue, goes and drains the queue, and does all the stuff, right? We have to figure out exactly how to get Rust to accept all of our like abstract trait lifetime things. But I think it's actually the algorithm is there.
Okay. So I think what I'm hearing is that we're gonna close the show, and we're gonna promise to have traceable stuff in the repo soon.
Yes, it's an IOU. It's just as good as traceability.
This has turned out to be a real challenge. That took us 3 hours of this, and obviously some working on the side.
Yeah, I mean it's not it's not an easy thing to implement. Like compacting garbage collector.
Compacting garbage collector in Rust.
Yeah, like I think in C we could have gotten it at least to compile faster. we'd have other problems, but yeah.
Okay. Well, this has been fun as always.
I think it's been really fun to do this sort of challenging project. Like it's also fun to do Towers of Hanoi in a language we don't know, but it's also fun to do like a pretty challenging project like this.
Well, I was unfortunately traveling this last weekend, so I did not actually get much time to like hack away. But I do want to spend some time like staring at this and trying to make this less crazy, unsafe and stuff.
Yeah, we're piling on the hacks, but I feel like if we get these tests in place, then we can spend some time doing exactly that. Just like coming through it, removing the unsafes, getting the type things more sensible, and having the tests sort of hold us to account.
All right. Well, it's been fantastic to see you as always, Dr. Barth.
Yeah, good to see you, Eric.
Have a good night.